Hey everybody in pre-cal. Yes, it's time for another Mrs. Smith's video. By the way, we are going to have a Teams meeting in the morning. So first period, make sure you're up nice and early, and I'll be allowing you entry into our meeting at 8 o'clock, or actually you can join a little bit before that, I'm sure. So be on the lookout, and you can bring me questions tomorrow during that Teams meeting about this material. All right, Chapter 7-2 pre-cal. Angle, sum, and difference, identities. Okay, I posted this already. I posted this nice formula sheet already on the wall, or as an assignment maybe even. Okay, so this is what you're going to use. This is going to be your right hand crutch while we get through these, all right? And after you do enough of these, trust me, you'll memorize the patterns. Okay, so like it says, angle, sum, and difference, identities. So that means we're either going to be adding or subtracting different angles, or we're taking a given angle and we're going to break it into smaller angles so that we can employ the one of the theorems. Okay, I'm going to start with some that are on your highlighted sheet. Now, it's an OpenStax pre-cal book assignment. You'll recognize the format. It's the end of the chapter stuff, and you're going to be looking at the highlighted or the starred. Okay, honors, you're doing both, and traditional, you're just doing the highlighted as per usual. If it's not highlighted, that's because it means it didn't let me highlight it, so you will have a red dot by it, and red dot equals highlight. So that means everybody's going to be having some of it to do. All right, the first thing we're going to talk about is I'm just going to go through some of these examples, and again, we're going to use these formulas. And we're going to use these formulas to break apart some given angles. Sorry, I'm looking for my markers. Okay. All right, and I have to keep my eye on the video because I'm going to upload these on YouTube, and I've got a 15-minute limit. So we're probably going to have 2 or 3 of these because I've got to do what I can do in 15-minute intervals. All right, so this is a Rex. This is from your highlighted sheet. Your highlighted sheet looks like, well, you know what it looks like. It's this, okay? This is your highlighted. Forget that I did not scribble that out. I didn't mean to. That one's absolutely still okay. So, but here it says highlighted plus red dot everyone and stars for honors, okay? And then it's a front and a back, okay? So I have posted that already under the assignments for Chapter 7-2, angle, sum, and difference, identities. So that's what I'm pulling off of. All right, number 4. Let's start with that. The instructions for this section say, find the exact value. So that means no decimals, right? Find the exact values. Oh, just to note, there's a section in here that you're going to have to use your calculators to check graphs to see if the graphs are identical. And you will have to put your mode in radians to do that, okay? Because you're going to have to... It won't understand it because it's not in degrees. So, and just a reminder to put it in your mode in radians, you're just going to hit mode. You go down to the 4th line, and it says radian or degree. Right now, radian's blinking, so I want to arrow over and land on radians, and I'm going to hit enter. And that'll lock it in, and then you hit second mode to get out. So when you go to graph, you want it to be put in radians, okay? Otherwise, you'll be very, very frustrated. All right, find the exact value. All right, cosine of 7 pi over 12. Okay, so you say to yourself, what 2 angles, okay, and I could say what 2 theta angles, when you can do subtraction or addition, it doesn't matter, okay? I'm going to use, because you can come up with an infinite number of combinations to give you the same answer, but I try to think as closely to simple as I can. All right, what 2 angles, when added, equal 7 pi over 12? You could also do this as a subtraction if you wanted to. All right, but our end result will be the same. So I'm like, okay, this is the same as cosine, okay, of 3 pi over 12 plus 4 pi over 12. So anybody would agree that 3 pi over 12 plus 4 pi over 12 equals 7 pi over 12. All right, so now you're like, well, let me shrink that down. Let me simplify those because we want to make them recognizable, at least for this section. So that's going to turn to pi over 4 plus pi over 3. Okay, those are recognizable to us from the unit circle. All right, so now we have cosine of alpha plus beta. All right, that's our combination right there, cosine alpha plus beta. So if we go back to the formula sheet and this is, all right, we're going to use this to spread it out. We're going to expand it using cosine of first angle times cosine of my second angle minus sine of my first times sine of my second. Okay, so that's the formula we're using because it's cosine alpha plus beta. We picked the alpha and the beta though. All right, so on the next page, we're going to work that out. So it's going to be cosine pi over 4, that's an alpha, plus pi over 3, that's your B or beta angle. Okay, and the formula reads this. All right, it's going to end up being cosine of pi over 4 times the cosine of pi over 3. So that's cosine of alpha times cosine of beta minus sine of my first angle or my alpha, pi over 4, times sine pi over 3. Okay, so this is the cosine alpha plus beta formula. Okay, so now we're just going to take these values that we know from the unit circle, and by now I hope you don't need your unit circle because these are you should know this pretty off the top of your head. All right, so cosine of pi over 4. Well, pi over 4 is a 4 family member. It's cosine and sine are both radical 2 over 2, so it's going to be radical 2 over 2. Cosine of pi over 3, well, pi over 3 is 30 degrees. The cosine of 30 degrees, or the x-coordinate at 30 degrees, is 1/2. Minus the sine of pi over 4, well, sine and cosine of pi over 4 are the same, so that's radical 2 over 2 again. And then we have sine of pi over 3, and pi over 3 is 30 degrees. I mean 60 degrees, my bad. This was 60 degrees, okay? And that's radical 3 over 2 as the sine value. So now we're just going to multiply. This is going to give me radical 2 over 4 minus radical 6. You can multiply those two together over 4. So that's going to end up with an exact value of the square root of 2 minus the square root of 6 over 4. So that's the exact value of the cosine of 7 pi over 12. All right, let's do another one. All right, let's get number 5. Number 5, okay, same thing. Find the exact value. Okay, so we're going to find the exact value. And this is from your homework. So we're going to find the cosine of pi over 12. All right, so you're going to look for any two angles that you can add together or subtract or whatever to get pi over 12. It doesn't matter. You're still going to get the same answer. Okay, so I'm going to look at this and say I'm going to use cosine 4 pi over 12 minus 3 pi over 12. Okay, so I'm going to looking for now the cosine of pi over 3 because 4 pi over 12 reduces to pi over 3 minus 3 pi over 12, and we know that reduces to pi over 4. Okay, now we use the cosine subtraction formula. So this is going to be cosine of A minus B. Okay, so you go to your formula sheet until you get really good at it and you say I'm using this one. So it's going to be cosine cosine plus sine sine, okay, of each of our angles. So alpha and beta. So remember, this is like my alpha and this is my beta. So it's going to be cosine of pi over 3 times the cosine of my beta angle or my second angle, which is pi over 4. Okay, and in cosine, the sign changes in the middle, so this becomes a plus. And now we have sine of my alpha angle, which is pi over 3, times the sine of my beta angle, and my beta angle, remember, is pi over 4. All right, now we pull these off the unit circle. Okay, so the cosine of pi over 3 is 1/2. The cosine of pi over 4 is radical 2 over 2. Plus the sine of pi over 3, which is 60 degrees, is radical 3 over 2. And the sine of pi over 4 is radical 2 over 2. So we'll multiply top times top over bottom times bottom. You have radical 2 over 2 plus radical 6. I'm sorry, 4. That should be 4. My bad. I had 2 on the brain. All right, and that's going to be radical 6 over 4. So the answer here is radical 2 plus radical 6 over denominator 4. So that's the exact value there. All right, I'm going to do another one. Okay, let's move on. Okay, I'm going to take number 10 now. Number 10 from the same section. This is like Rex number 3. Remote example. And this is number 10 on the highlighted sheet. Okay, and just to make sure I know what the instructions are for number 10, it says for the following exercises, rewrite in terms of sine of x and cosine x. So that's what we're going to do. All right, in terms of sine of x and cosine of x. Well, we have sine x plus 11 pi over 6. So this is given. Okay, so you recognize here, all right, I've got alpha plus beta. So you go to your handy dandy formula sheet, and your handy dandy formula sheet tells you that sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Okay, notice the signs SIGN and SIN stay the same. Okay, so now we're going to do sine alpha cosine beta plus cosine alpha sine beta. All right, so alpha is x and my beta is 11 pi over 6. All right, so equals the sine of my alpha, which is x, okay, times the cosine of my beta, which is 11 pi over 6. I'm just following that formula sheet. All right, I know it's going to remain plus here. So now it's the cosine of alpha, which is x, times the sine of my beta angle, which is 11 pi over 6. Okay, so we're going to say, all right, the sine of x, all right, so that's going to be sine x over 1. And the cosine of 11 pi over 6 is radical 3 over 2. Plus, you write sine, I'm going to put cosine x over 1. And that's going to be times the sine value of 11 pi over 6, which is negative 1/2. Straight off the unit circle. Top times top over bottom times bottom. This is going to give me radical 3 times the sine of x over 2 plus, this is going to give me negative cosine x over 2. So now we can move those two in together and we can actually make this like a fraction. So it's better if you do like this, radical 3 over 2 times sine of x, and then that's going to be a negative, so minus, and then you can make this a 1 over 2, so that's 1/2 cosine x. So there we have it. We have done it completely in terms of sine and cosine. So that's number 10. All right, I got to pause the video and start another one. Be right back.